They're going to be logging in. Hey, Orly, good morning.
Hi, everyone. Nighttime
So
for
we're
me.
missing, yes, that's right. It's evening for you. Thank you for making it. I know, is it 8 o'clock?
Yep, it is.
8 p.m. So Orly's calling in from Israel. So there's a little bit of a time difference, but it's a little earlier for us. So it is now 10 o'clock, so we can go ahead and get started. So far, we have 46 people logging in. So as you come in, if you can just mute your mics, I'm going to go ahead and mute it on our end. So for everybody, this is being recorded, and we're going to be publishing it soon on the YouTube channel so you can see it. This is a short 20-minute snippet, and we're primarily going to be covering everything that has to do with desalination. So welcome. Today we're having Orly, that's going to be logging in from IDE Technologies. This is, we've got webinar number 8, here we go. So number 8 of a 12-part series. These are some of the ones that we've done so far. And with that, Orly, I'm going to go ahead and switch it over to you, and it's all yours.
All right, great. So should I maybe, I'm going to share it from my desktop. Is that okay?
Sure, go for it.
All right, so just give me an okay that you can see it.
Yeah, we can see it.
Okay, great. Okay, let me just present it and I'll be on my way.
And just a quick note here, if anybody does have any questions throughout, go ahead and punch them into the chat box. This is going to be recorded. At the end, we're going to have a 5-minute period where we can go into some of the questions and answers. Okay?
All right, so happy to be with you guys, and let's go because we have no time, right? Principles of RO Desalination. So what I'll be trying to cover is basically how the desalination process works, a bit about the filtration type and what osmotic pressure actually is, the structure of the membrane and some main terminology that's important to know, and the RO performance system and how we can affect it and reach our product specifications that we are required for. And then just a bit about where the market is going with prefabricated design models, and a case study to kind of wrap it all up. So as Alex already said, I work at IDE. It's an Israeli company established in '65 with worldwide offices and installations in over 40 countries, about over 400 installations. We mainly work on desalination processes, but also industrial wastewater and reuse. So it's desalination of RO and thermal. Today we're going to be focusing on RO, and I know we're going to have another webinar coming up of a colleague talking about thermal desalination. So heads up on that one. These are just a few mega-sized plants that IDE has been involved with designing and, up to running them in Sorek, Israel, 150 MGDs. Now we're working on Sorek 2 after we won the bid, so that's a very exciting project here for us. The Carlsbad, the 55 MGD, the largest desalination plant in North America. A few large thermal projects in China and also in India. And so this is basically what we do. Let's go into it. So I'm going to be talking about the desalination process, and it's basically a membrane process for RO. When we have to know, we're not going to talk about it today, but basically the pre-treatment of the system is very important, and it will be characterized by the physical characteristics of the water, and to make sure we have a smooth operation of the membrane system. And then the chemical content of the feed water will give us the kind of membrane configuration we want to choose, and will let us know if we need post-treatment to chemically stable the water, depending on where the water is going, if it's for drinking, agriculture, or an industrial use. So if we talk about, main filtrations systems, then we can see that we have reverse osmosis giving us the smallest pore size. This is like a mean size pores, and basically what passes the RO membrane is water and a very small amount of salts. Just giving you different sizes of what would pass in ultrafiltration and microfiltration, nanofiltration. So for RO, we're basically talking about dissolved particles, okay, and basically water and some salts. RO would be talking about filtration type. So it would be this right side over here, cross-flow filtration, meaning we always have a feed flow and a brine flow coming out while we're producing our permeate, versus dead end, let's say in UL filtration, where we are feeding the water and accumulating the debris, and every now once in a while we have to backwash in order to clean off the membrane. So that's kind of a difference in the filtration type. So to understand reverse osmosis, we have to understand the most basic point, that is osmotic pressure. What is osmotic pressure? So if we look at the top here, and we have this system that has one side of diluted water and the other side of concentrated water, each one has a different chemical potential. So the diluted water has higher chemical potential, and this in the middle here would be a semi-permeable membrane. So the system will want to go towards equilibrium, meaning the water would want to pass from the diluted side to the concentrated side. And this difference in hydrostatic pressure, as you see here, is the osmotic pressure. This is the system at equilibrium. So in order for us to desalinate water, what we have to do is inflict pressure from the concentrated side, pushing the water towards the diluted side. Okay, and the pressure that we have to inflict has to be above the osmotic pressure. So we're talking about, let's say for every 1,000 ppm TDS, we're going to get we'll get around 1 bars of osmotic pressure, meaning for seawater of around 35,000 ppm TDS, we have to at least give 30 bars, and only then we would start our reverse osmosis process. Of course, the higher the pressure, which I will talk about just soon in the next few slides, the higher the pressure, the more permeate we are able to produce. And this is a trade-off with other aspects that we'll go into in a minute. So if we look at how the membrane is kind of the structure of it, this is a spiral round membrane. This is the most commonly used, not the only one, but it's very wide ranged used. What we can see here is the membrane envelopes, okay, and in between there's a spacer. So the feed water is basically a channel here running alongside the envelope. The pressure of the feed that we're giving is pushing the water into these envelopes, okay, and then the water kind of slides all the way down here and comes out the permeate tube. Is collected in the middle here in the permeate tube. So the water is the feed water channel is basically the feed brine channel, meaning that slowly we're desalinating, and then at the end of this phase, then the water that was feed is now the concentrate, all the salts and water that did not go into the the membrane envelope. Okay, so here we just see pictures of some pressure vessels. I'm sure a lot of you are familiar, and this is a look into the pressure vessel where we see the top of one of the membranes and see how it's the membrane is slid into the pressure vessel. So some main terms that are important to know when we're talking about RO. Recovery. So the recovery is the ratio of the permeate quantity over the feed quantity. This is a percentage, so basically meaning if we feed 100% of our feed stream, and normally 45% recovery, between 45 and 50 is common, then that means if we take 45, we have 45% of the water that enters will turn into permeate, and 55% will be brine. Flux. Flux is the membrane throughput. Okay, we're usually talking about the volume of permeate per unit of time per area. Okay, and this is another parameter in the design of reverse osmosis that is very important, and I will show you in a minute how we use it and how it affects our system. So salt rejection and salt passage, which are basically the opposite one of the other. Salt passage showing us the amount of the percentage of dissolved contaminants, what does pass through the membranes, and salt rejection being showing us the opposite, what from the concentrate is removed from the system. So this is just to show you how inside a pressure vessel, one membrane will sit one after the other. Normally in RO desalination, seawater, we are talking about between 7 and 8 membranes. And so basically they're connected here. We'll have the feed of the seawater, let's say, and in the pressure will push into the membrane the permeate water that will be collected in the permeate port, and then the rest of the water that would still stay out here and turn slowly as we move down the line of the membranes into the brine and come out the brine port. Just to see how the different parameters are affected. So if this is our pressure vessel, membrane 1 through 8, and we are beginning at number 1. Okay, so we have our seawater. Our feed water at this point is the lowest concentration. We have the highest pressure that we just gave our high pressure pump, and we're producing a very good quality permeate and a very high flow of permeate. And then as we move down the membranes, you'll see that the feed water is getting more and more concentrated because more and more is turning into permeate, so it's becoming more and more brine. Our pressure is reducing because we already used it for desalination for the first membranes as we go along. And because our feed water is saltier and the pressure we have for the reverse osmosis is lower, then naturally we're producing less permeate and less flow rate. Okay, so this is just showing you what happens over the 1 through 8 membranes, and then eventually what we have is the average of all of these as far as quality and quantity of the permeate. So main parameters that we already, I already said a few words about and affect the design and the operation of the desalination plant. Some of them we control and some we just have to take into consideration. The feed pressure, temperature of the water, the recovery ratio in which we choose to operate, and the feed water concentration. And then there are some things that happen during operation, you know, that we have to take into consideration. Membrane age, the fouling that happens over time, the cleaning procedures that are being taken and their duration, they all affect the membranes over time and can affect also the quality and quantity of our permeate. So if we just look at each parameter that I mentioned before, we see that if we increase feed pressure, then we're of course increasing permeate flux and we're increasing salt rejection. With higher temperatures, let's say we're working now in the same plant, working in the summer. Okay, so we're going to increase our permeate flux and reduce salt rejection. So we're getting worse quality during the hot season and than we are in the cold season. And then recovery, for the most part, is not really affecting our permeate flux and salt rejection. And feed concentration is going to basically, the saltier the water, then the lower the flux and the lower the salt rejection, of course. So how can we, you know, take all this and do the best to design the best plant we have, meaning we want the good water quality, the low energy, and low chemical concentration if we can. Okay, we can basically affect all of these by influencing the recovery, the number of pressure vessels, and determining the flux, the type of membranes we choose. We may want to have an ISD configuration, meaning a mix of membranes in one pressure vessel, choosing maybe tighter membranes in the beginning, giving us the good quality, and then more open membranes to follow, giving us reducing the energy as much as possible or still giving us the ability to give the right water quality that we need at all times. We can play with pH. Normally when we have boron requirements that are very common wherever the water is used for agriculture. So there are lower restrictions on boron. So we may have a second stage of RO. And there we want to increase pH to around 10 to put the boron into the right conformation to be better rejected by the membrane. And we can inflict different pressures between different stages of RO, increasing brine from stage 1 and production of the second stage. But of course, nothing comes without a cost. So if we want to lower recovery because we want lower pressure, okay, then we have a larger intake and we have larger pretreatment. Okay, so this is also larger capex, and we also have more chemicals because now we're treating more feed water. On the other hand, if it's important to us to have low energy, you know, it depends. Every project has their focus on what's more important. We always start with everything's important, and then we say, okay, but you can't have it all. And then kind of see where we want to put our focus in the design. The same with the number of pressure vessels and flux. So if we increase or decrease the number of pressure vessels, we're decreasing the number of membranes, so we have less capex, but we're increasing the flux. Increasing the flux will increase the feed pressure and increase the specific energy. The same, as I said before, with kind of working with different types of membranes. We want to get good quality, but we don't want to give too good quality, you know, not better than what is required, because that will cost in energy. So when we're monitoring, after we've designed, and we kind of want to monitor the system and see how it's performing, there will be process parameters that are important, and also equipment parameters. So we can make sure that we're working at the right flow rates and recoveries. We can check salt passage by monitoring conductivity and concentrations, checking the quality of the water. And we can make sure we're working at the right pressure and pressure drop, make sure that we're cleaning the membranes when needed and not working over too high pressure drop over the membranes or the cartridge filters that usually come before them. And just monitor that we're working at other parameters that the turbidity and SDI that are kind of an indication of the proper pretreatment, and temperature and pH are things. Temperature is a given, but we just have to kind of know where we are with it, and pH is usually important when we're talking about boron again. And those are the process parameters, and more parameters are the equipment. We have to make sure that the equipment, the pumps, are giving us the power consumption that they were supposed to, that we're operating at the right pressures and temperatures. As far as the equipment, that there is no increase in temperature, vibration, or noise on the motors. And again, physical things like leakages or any corrosion or breakage. Leakages, let's say in the connectors between the membranes, can cause increase in salinity, and then we'll know once we see an indication, let's say, that our quality of our permeate is not as we thought it should be, then we know that we're something might have broken in between the membranes. Okay, so that was kind of basic terminology, really quick. In the last few minutes that I have, I want to kind of show you that where the market is going these days. We're trying to kind of reduce time, reduce costs, and kind of give our customers the best solution we can. And this is being done at the recent years in different size scale projects with the modular prefabricated design, meaning that we're going to design these units and fabricate them in a workshop. Okay, and what happens is, why is it saving time? Because we kind of can work at the same time in the workshop and on the ground with civil works and preparing the site. So we can do them at the same time. We can work with people that are experienced in a environment that is under control, rather than more risks that happen on site. And it is something that is very attractive these days to different clients. Basically, it can be prefabricated and tested, and then you see it can be shipped very easy because it comes apart into these sizes, container size parts. When we're talking about we have different sizes of these units, so it's basically putting together the best for our client. I put a picture here of Lego because we can have different sizes. We can have more small units, and then we have higher availability, but maybe that will become versus cost. So it depends what each client is looking for. So just for a small example, this is a plant that is now being we're working on in Chile. So we have our big prefabricated units. So there are 5 of them, and just so everything is being prepared on site, and they will just be brought to site and installed. And then this is how they look in the workshop and being inspected and tested, and bringing them to the site with the least amount of any errors. 2 minutes for Bonaire case study. It's actually a very small plant that we're building now on the island of Bonaire. And what's interesting about it, this is just a layout. We see the pressurized pretreatment, the prefabricated SWRO units going into these 2 tanks, and then the final stage of BWRO to give the final quality. What's interesting here is, basically, it's a small island and the nature preserve, so they wanted a chemical-free system. They wanted low energy because energy was very expensive on the island, and they wanted high water product quality, giving them a low conductivity and a low boron. So we had to kind of put together how we're going to give them this whole thing. We wanted to give them low recovery and low flux. This was helping us also with the energy and also with the chemicals, because it would reduce scaling on the membranes. They couldn't have a CAP or cleaning system on site. It wasn't an option. On the other hand, as we said, reducing recovery and flux was going to hurt our quality that we couldn't compromise. So we kind of found a way that when we have extreme cases of high concentrations in the feed water, when that happens, they do have an option of working with 1 less unit and then increasing their flux. Increasing the flux in the SWRO will improve their water quality, and we will still be able to give them the water quality at all times. As I stated for the boron, we usually increase pH for the BWRO units for the 2nd stage of the desalination, and here it wasn't we couldn't do it because it was a chemical-free system. So we had to make sure that the quality we're feeding to the 2nd stage was high enough to pull everything together. And this just to show you that they're working on site here. And this is the skids being prepared for the RO units in the workshop. And that's me.
Perfect. Thank you, Orly. Thank you for that. I know we were cutting it pretty close there. We're at exactly 23 minutes, guys. I know that I try to keep this as short as possible so everybody can keep going. This is more of a kind of a coffee break presentation. So thank you, Orly. If you have any questions for Orly or for myself, you have our emails. We have a few people that were sending in some questions. So maybe if you want to go over them here real quick. So I have one question from Joshua Brooks that asks, so what properties of the salt water make warmer water advantageous with permeate flow? So it's just talking about temperature difference and how temperature affects your permeate?
So the warmer the water, basically it affects the membrane pores, and the pores are maybe more open and it's more porosive. So it lets more of the salts pass through the membrane, and then we get worse quality during the hotter seasons.
And if I understand it correctly, the colder the water, the more pressure you need, which means that now it's also negatively affecting performance on a membrane.
The best quality, as far as quality, when you have the colder water, you're getting the best quality because the pores are closed and they're passing less salts. But because the pores are closed and you're getting the better quality, you're also paying with energy. So that's the highest pressure you would have to inflict on your system.
And do you have a sweet spot for temperature? Is there a specific temperature where you're testing it and monitoring it when you're doing it in-house?
No, we have to kind of take what we have. It's very important to us to know what is the minimum and maximum temperatures that are going to be in this specific area. And we have to make sure that we can cover them all, as it's not something under our control. So we have to make sure we can give the quality and the pressure we need throughout the whole range of temperatures, as well as feed the TDS. You know, if the water is sometimes saltier, a bit more or a bit less, we have to make sure we cover this in our design.
Okay, thank you. Any other questions? You can punch it into your chat box, or don't be shy, go ahead and turn on your camera. We can do a little face-to-face. Evan, I know you always come up with questions right after we hang up, so if you have any questions, go ahead and punch them in. I want to thank Orly for taking the time, and IDE Technologies and everybody from IDE to help us put this together. If you don't already follow us, go ahead and follow us on LinkedIn. We have a pretty active community, and we try to post some new articles and some of the things that are happening in the water world. For next week, we are going to be covering turbidity and some of the monitoring and calibration around probes and what we're going to be doing. So thank you very much, everyone. If anybody wants to stick around and go for any questions or any other comments, we invite you to do so. And if you don't, thanks again for coming, and we will see you next week. So Evan, please tell me you have some questions for me. You're always the last one to have some questions. No questions today? Well, Orly, looks like we're the last ones here, or a few of them. Thanks again for this. This went really good.
It was my pleasure.
You know, we got a pretty good group. Let me see if I can get this over here or not. All right. Looks like we got a pretty good group. Oh, hey, Joshua. Thank you for sticking around. No.
Yeah, I've got a quick question. First of all, I don't even know how I got on the email that gave me this link, so I'm entertained. I'm doing a doctoral thesis on desalination right now in an aerospace lab. Nice. So I'm very much kind of out on my own on all this. So it's very interesting. And my quick question, I might just follow this up with an email as I come up with more stuff, but is there a way to get, I saw that this webinar was being recorded. Can I get a copy of the other 8 or 7 mini-series webinars to kind of review some of this stuff?
Yes, of course. They're going to be published on our channel shortly, and they're going to be all in there. We have 8 so far, and we have a couple other ones that we've done, not part of the webinar series or a little longer. But yeah, I will be sending those out and sharing them with everyone, so you'll get a copy of that.
All right. Well, thanks for your time, guys.
All right. Thank you, Joshua.
Bye.
Bye.